Hi. So I've been through this setup now and I've written out in a bunch of areas to try and help speed it up. So I have a few ROPs and I've basically written out some of the pop sim stuff, and then obviously the volume simulation, I've written that out, and then I've cached out the particles. So besides that, nothing much has changed except for some cleanup. And I'll just show you inside the PopNet. I have gone with 3 separate sourcing arrangements here for the one particle sim. So just to give you a quick overview of what those are, I haven't changed. 2 of them are the same as the ones we made in the previous video, and then I've added a 3rd one. So if we look at these 2, I put down a pop group and just called one of them main pop and second pop. And basically the main one is, and let me bring up the flipbook. So here you can see I've merged 2 of them together and just gave them colors so we could see how they look apart from each other. The yellow one is the main one. So that's basically the particle sim that's being 100% advected by the volume sim. And the purple one, I'm using the volume as a force, not as a velocity advector. But I'm still forcing the points to remain inside the sphere. So I'm pretty happy with this because what I get is I get a sort of like a very dynamic interaction in the yellow from, say, how the shield would be reacting to the impact. But then I get a blast kind of shockwave from the purple element. So every time there's a bright flash, it's followed by this shockwave effect that ripples through almost the whole shield. So I think that's actually turned out very effective. It adds an extra high speed, highly dynamic element to each impact. And then for the 3rd one, what I've done is I've just, instead of using all points in the source, I've just used points and I've set a much lower value. So if let me just check. So this is also just set to update velocity. So it's pretty much the same as the main sim. So I can take a look here. And what did I call it? Inner pop. So I have a plan for this one, and it's to add an internal network of lines basically, which I'm hoping would be the sci-fi element. So where these layers are looking pretty magical, we can add a sci-fi element here. So I've reduced the amount of points, and basically I want to try and use those points to connect adjacent pieces on those points to generate some interesting lines and triangles inside. So let's just see if this is working. So if you have a look here, the difference in point count is pretty drastic. So let me write that out quickly. So the downside to doing it the way I've done it now is obviously I'm actually simming the hold up again. So every single one of these layers is simming just to generate the one layer. So it's not ideal. And for me, I did it in that way because, as you saw, I was just experimenting basically inside the DOP. So it's extremely quick to plug in new sources, try different settings, and just merge it all together to get a very quick update on what I want to try. Luckily, this isn't a super slow sim, but it's kind of one of the byproducts of the way I like to work, which is as quick as possible and experimenting as much as possible. So make this bigger. So this kind of approach is great for experimenting and getting really interesting results quickly, because I can try different options without even leaving the DOP. But once you're done, it would be better to copy these out into their own DOPs so that you don't have to rerun the whole sim every time you just want to update one of these. So there we're left with pretty much exactly the same sim as the main one, but much fewer points. So let's see what we can do with that. My idea was to use connect adjacent, which is usually you'll see being used to generate glue networks for rigid body sims. So I set that to connect adjacent points just to make sure it's using the points of our sim, and this looks pretty cool already. That's just drawing a line between each one of those points in the sim. So I like where that's going. I was worried it was going to flicker around and change too often, but it actually looks pretty stable as an effect. There's nothing crazy going on every time it reconnects or anything. So I really like that. So I'll keep that one in my back pocket as well. And you're probably starting to see a trend here along with the way we worked on the portal. I've sort of I've funneled everything down through here, and I seem to be using the same setup to see if I can branch out with many different layers. So it's a good general approach and understanding of how to build on something very basic and to layer it all up, and it should hopefully look extremely complex when it's done. Alright, so these are the nodes I just dropped down to visualize. Let's jump back onto these main two and see what we need to do to kind of bring this home. So we've got these points. I'm just going to merge them together. And let's set some attributes here. And I'm going to actually put down a color as well, because what I want to do is just amplify the color we have here. So if I use ramp from attribute, set this to CD. So now we can remap the colors that we already have from the simulated points. And I basically just want to kind of cool off most of that sim. So we can cool off all the points so they cool a little bit quicker, and we keep the source, or the brightest points in the source, we make them a bit brighter. So like this value is arbitrary because we'll use this in the shader somehow, but it's more just to make sure we get a very drastic difference between what's considered the hot spots of the effect and then how quickly it cools into its cool spots. So So this isn't basically an age thing at the moment, it's just the colors from our sim. I want the difference between the hot spots and the dark spots to be more extreme. So something like that, and then in this wrangle I'm going to take the color and multiply it by the actual age. So I'm going to put that into a ramp because I want the points to either disappear in terms of the alpha or the color before they're actually dead. So we'll make a ramp based on age divided by life. And we're just multiplying the existing color. So if I look at a bit down the line here, those older points should be going to 0 in the color. And then what I can do is just base the alpha on CDX, say. So we get a bright flash and the points start to fade off the older they get. So that sort of cleans up that sim a bit. And I'm just going to set an arbitrary p-scale here when we move on to our test rendering. So something small. And then I'll put down another color and we'll just define the basic look, because what I do want to do here is, if we sort of replicate this with all of our experiments here, I want to merge those all together and then potentially adjust the colors for each layer together, so we can define the look of the whole effect before we even jump into shading and rendering. So I'm just going to remap color again, but we'll change this to some nice goldy yellow color. And I always try and define the saturated color here, and then I'll kind of bank that, so that becomes my cool saturated color. So that's from there I choose the hot version of that. So less saturated, and then brighten that up, so I kind of end up with that kind of ramp. So I've chosen my base saturate, and then I pull it back and I ramp right up to make my hotspot. So at the moment I'm not 100% sure what I want, but I'll stick to something like this. So there we're completely independent of the alpha as well. So those points will just keep existing until they fade away into nothing, but we'll make sure we have some control over the color of the bright spots and of the color that those bright spots turn into afterwards. So something like that. And then obviously the big thing we're missing is we need to make an inverse transform of one of these transforms here. So we have, let's take this one. So we have the shield itself, and this is the animated one, and then we're moving it to the origin. So what I need to do is make a reference copy of that, because at the end of this whole network we need to obviously move the effects back to the moving position. So invert transforms, and there we should have the moving shield. So I'm going to flipbook this. Just to test it out. So this has moved forward, it's obviously not still at the origin, and now it's sliding back along the floor. So that seems to be working fine. So that's good. What I've done with that is I've proven that the system works. So now we can really get stuck into the fun part and start messing around with these layers, similar to the way we did with the portal. We had some base sims to work with, and then I just kind of went mad and tried things. So I'm going to take these sims in the next video, and we can try a bunch of other SOP techniques I usually use to just kind of make it look as good as possible. So I'll see you then.